Well, it's a great privilege for me to welcome someone who, of course, is extremely well known in Cambridge circles and beyond, Sir John Meurig Thomas, who was previously director of the Royal Institution in London. He was holding there the chair of chemistry, which was actually originally created for Michael Faraday back in the 19th century. Professor Thomas was also head of the Department of Physical Chemistry here, 1978 to 1996. That's a really long innings for being head of department. I can see some people shaking their heads. He was also Master of Peterhouse from 1993 to 2002. And he's still, in fact, an honorary professor in the Material Science Department. And if that wasn't enough, I know he's quite a prolific writer of articles, another textbook as well, but articles like the one you might have seen to mark the anniversary of Lawrence Bragg only about a week ago in the Times, and I think some other materials coming along about various great figures in the history of science. So we're especially delighted that today he's going to talk to us on the genius of Michael Faraday, so thanks very much, John.
Mr. Chairman, ladies and gentlemen, on the wall of his study in Berlin in the early 1920s, Albert Einstein had three portraits: Sir Isaac Newton, James Clerk Maxwell, and Michael Faraday, because he believed that the greatest change in the understanding of man's concept of the physical nature of the world since Newton came through the joint experimental work of Michael Faraday and the theoretical interpretation of it by James Clerk Maxwell. Writing in the Times on August the 29th, 1931, the date is significant as you'll see in a moment, Lord Rutherford said something like this: "The more we examine the work of Michael Faraday with the perspective of time, the greater we are impressed by his unrivaled genius as an experimenter and natural philosopher. When we consider the magnitude of the impact of his work on the progress of science and technology, no honor is big enough to be paid to Michael Faraday, the greatest experimenter of all time." So there, ladies and gentlemen, you have arguably the greatest theoretical physicist and the greatest experimental physicist of the 20th century, bowing and adulating the memory of Michael Faraday. But that's not all. Every electrical engineer in the world adores the memory of Michael Faraday, because it was he, on August the 29th, 1831, in the basement of the Royal Institution in London, who discovered electromagnetic induction, which in a word simply means that you can extract continuous electricity from a magnet, from magnetism. Electromagnetic induction. I'll illustrate that by a slide or two a little later. It's the principle of the dynamo. All the electricity that we use in the world, more or less, except that generated by a fuel cell, goes back to Michael Faraday. He is really the generator, the creator of a modern world based on electricity. But now, the physicists and cosmologists, when they contemplate the contribution of Michael Faraday, recognize that he was the first man to talk about a field. Field theory started with Michael Faraday. But, he talked about magnetic fields, electrical fields, gravitational fields. In textbooks of cosmology, you'll see reference to Michael Faraday. Also, you'll see reference to the fact that he was one of the first to talk about the grand unification theory, the belief that all the forces of nature somehow were intertwined and interconnected. We'll come back to that a little later. Now, physicists praise Faraday. Every elementary textbook on physics will start usually by experiments on the discharge of electricity through gases, which Faraday studied, on the electrostatics that Faraday examined. That's to say, he demonstrated in a very graphic, dangerous way how a particular object, a body, a metallic body, if you charge it, all the charge is on the outside, it doesn't go inside, which is a salutary thought when you're flying in a jet through a lightning strike. You just thank Michael Faraday that he's reassured you that the charge is on the outside. It's known as a Faraday cage. And in surveillance and all sorts of other applications, Faraday cages are much used. But he also made some prodigious contributions to the study of capacitance. The unit of capacitance is called the farad. I don't want to go into details, but dielectric properties, which scientists here know all about, were investigated in detail and in a brilliant way. The Nobel Prize of Peter Debye in 1934 starts by praising Faraday. But, 2 chapters of it. It's an amazing testimony if he had done that alone. But also as a young man, he liquefied 6 gases that had never hitherto been liquefied. He believed in the continuity of state, that provided a material was thermally stable, it could go from a gas to a liquid to a solid. But even as a young man, he realized something which, if he'd only done this, he would have been made immortal in the history of physics. He realized that there was a critical temperature, which meant that however high the pressure you apply on a gas, if you're not below a certain temperature, it will not condense. That's the critical temperature. Well, there was another experiment which he carried out in 1845, which was really sensational. And what he did was to take plain polarized light, and he allowed it to pass through an electromagnet that he had himself built. Now, he didn't switch on the magnet until he'd studied that the light was going straight through. Then he switched it on and it tilted. Now, that's the beginning of magneto-optics. That is the proof that light has a magnetic component on it. If that were not so, you really wouldn't be able to understand how things like the telephone, the iPod, the iPad, the television, and all the various things that we use in 21st century life work. You see, Newton's physics help you to predict the precise instant of sunrise and sunset. Tells you the orbits of planets and comets and space vehicles. It tells you in an indirect way the ebb and flow of the tides on all the shores of all the oceans of the earth. But Newton's physics don't help you one iota to understand the reception and transmission of radio waves and the mechanism of the telephone, and the iPod, and the iPad, and television, etc. For that, you go step by step back to the work of this man, Michael Faraday, and then to its interpretation by a young fellow of Trinity College, Cambridge, who started life in Peterhouse. Things got too hot for him, and he moved to Trinity. Anyway, physicists, therefore, I've told you enough about how much they admire Faraday. Now, chemists say, well, of course, he was sensational. Faraday's laws of electrolysis are among the most accurate laws in the whole of the physical sciences. You see, when he studied this phenomenon of electrodeposition, shall we say, of nickel and copper, silver and iron, whatever, there was utter confusion at the time. This was 1832. People wondered whether it was the size of the vessel, the shape of the electrodes, the temperature, the concentration of the solution, or whatever. No, Faraday, after a few weeks' work, demonstrated there were only 2 things that mattered. The quantity of electricity that you pass and the electrochemical equivalent of the material that you're depositing. Those are the only 2 things. Now, the quantity of electricity required to deposit 1 gram equivalent is called the Faraday. No man in history has 2 scientific units named after him, a farad and a Faraday. So one should be proud of it for that reason alone. Now, electrolysis, I don't want to go into too much scientific detail because I do want to talk about his religious convictions and what it meant to him in this lecture, but there are many things I could say. Helmholtz, in fact, when he gave the Faraday lecture in the Royal Institution in 1883, pointed out that if you looked at Faraday's laws of electrolysis carefully and analyzed what they meant, they told you that electricity came in units. It was quantized, as it were. It came in ions, as it were. So this is a very interesting scientific matter which I don't wish to pursue. Now, what else did he do chemically? Well, he's the man who discovered and introduced and extended magnetochemistry. We all know about ferromagnets. We don't all know about paramagnets and diamagnets. If you take some substances, bring them close to a magnet, they'll be attracted into it. You take some other substances and they're repelled. Those are paramagnetic and diamagnetic, respectively. Faraday spotted something. He had this genius picking up facts which nobody else had ever noticed. Nitrogen, hydrogen, carbon dioxide, they were all diamagnetic. But oxygen was paramagnetic. And let me tell you how he proved that, which again shows his experimental genius. He had his electromagnet. He wanted to test whether this gas was attracted or repelled by a magnetic field. He blew soap bubbles of oxygen. And when the soap bubble of oxygen went, it got stuck. Whereas nitrogen and hydrogen and CO2 went through. Marvelous. We had to wait 90 years till quantum mechanics came along in order to be able to explain that. And the facts were incontrovertible. He also looked at the magnetic properties of all sorts of things, including blood. Max Perutz used to say that one of the most influential papers that he ever read was Linus Pauling's 1936 paper in the Proceedings of the National Academy of Sciences. And Linus Pauling starts that paper by saying, in 1845, on September the 21st, Michael Faraday looked at the magnetic properties of blood. And then he explains how hemoglobin and oxyhemoglobin, one is paramagnetic, one is diamagnetic. Absolutely brilliant. Now, there are other chemical things that Faraday did. He was the man who discovered benzene. Now, you know, the whole world uses benzene on a massive scale. And the dyestuff industry relates to benzene. How did he discover it? Well, his brother used to work with the London Gas Company and used to deliver gas cylinders to the Royal Institution. And Michael would go and meet him and take back the empties. Sometimes he had to wait for his brother to arrive. And he would smell the residual liquid, which was very smelly, called it aromatic. And he analyzed it, and it's benzene. And it was produced from whale oil, which is what people sold those in those days in order to get gas and so forth burning in London. Well, he did many other things. He was the originator of photochemistry. He carried out some experiments at the Royal Institution in which he had benzene and chlorine in a vessel. And he heated it, and nothing happened. And he wondered whether he could get them to react. Took them to the roof of the Royal Institution. There was just enough sunlight there, and they didn't explode, but they formed hexachlorobenzene. That was 1827, a very, very long time ago. Chemists who are present here know that you can't live without photochemistry these days. So all this is an incredible collection. There were many other things. I mean, superionic conductors, which are all the rage. You can't run a fuel cell unless you have a superionic conductor. They were first reported by Michael Faraday. And I could keep you here for a very long time, giving you other examples of that. But let me just mention two other things. In 1826, Michael Faraday undertook an initiative on two fronts, which are still with us. Number one, he started the Friday evening discourse program in the Royal Institution. In the winter and autumn and late spring months, every Friday, he would invite a person to come, not necessarily a scientist. You could have a man talking about poetry or ballet or clouds or viruses or whatever. He himself initiated this program, the Friday evening discourse. There are at least two people here, Tony Hewish and Colin Humphreys and maybe others, who've given, sorry, John, I beg your pardon, you've given two, I believe. I'm so sorry, because you gave one before I did, I remember. Sorry. Anyway, the Friday evening discourse. The other initiative was the Christmas lectures for a juvenile auditory, as he called it, the children of London and its environment. And and 6 lectures. And he gave those 19 times. I gave them once and I nearly collapsed. Well, of course, I had television cameras on me, which Faraday didn't, of course, so that makes a big difference. So there we are. How did all this begin? This man who left school at 13, barely 13, equipped only with the rudiments of reading, writing, and arithmetic. He went to work as an apprentice in a bookbinder's shop in Marylebone in London. He was born a mile south of St. Paul's Cathedral. Blacksmith's son of a very strict religious denomination, the Sandemanians. I'll come back to that in a moment. He went and worked in this place, and one day, a very kindly customer who had noticed how alert he was, how interested he was, and how very, very self-propelled he was, offered him a ticket to go and listen to the last 4 lectures given by arguably the greatest scientist in the European firmament at the time, Sir Humphrey Davy, at the Royal Institution. First one was on February the 29th, 1812. The others were for the rest of the month of March. Well, here is the sort of shop in Marylebone. There's the young Faraday. He read omnivorously. I mean, he read huge collections of books. Encyclopedia Britannica, he describes how he went through the account on electricity in the Encyclopedia Britannica, which runs to about 100 pages. He was about 19 to 20 at the time. Well, this is the man who influenced him, Sir Humphrey Davy. Now, by the time that Davy was seen by Faraday, sitting above the clock in the Royal Institution in 1812, Davy had discovered sodium, potassium, calcium, strontium, barium, and had demonstrated the elemental nature of iodine and chlorine. He had invented the miner's, well, no, he hadn't quite by that time invented the miner's safety lamp, but he had discovered the anesthetic properties of nitrous oxide, age 21. He had discovered what are known as clathrates. The energy programs of Japan these days are dependent on methane clathrates, but the clathrate, for his first ever identification, was Humphrey Davy's at the Royal Institution in 1810. Davy did so many other things. He demolished Lavoisier's contention that all acids contain oxygen. Why is that important? Well, it's important. There's a remnant of it in European languages still. In German, the word for oxygen is Sauerstoff. There's an equivalent word in Dutch, which I can't pronounce. There's also a word in Russian, kislorod, which means oxygen. That stuff that produces sour material. Well, Davy demonstrated that wasn't true. Hydrochloric acid contains no oxygen. In fact, all acids contain hydrogen. That was a major step forward. There were many other things that Davy did. Well, Faraday listened, absolutely mesmerized by this brilliant individual who had a felicity of literary and poetic expression combined with brilliant scientific discovery and presentation, careful preparations beforehand, wonderful demonstrations. Davy was so impressive that Faraday wrote out almost every word that he could remember and rewrote them, and then put in diagrams, indexed it, bound it, and then sent it off to Davy to ask for a job. Wrote to him and gave his own testimonial. Here's the Royal Institution. It wasn't quite like that in Faraday and Davy's day. It's not quite like that now, too. The traffic system is slightly different. But here's the book that Michael Faraday gave to Sir Humphrey Davy, sent it to him. It's a document of Mozartian perfection. If you look at it, there isn't a single error. Everything is so perfectly done. This is how Davy answers him. He wrote to him on Christmas Eve, 1812. I am far from being displeased with the proof that you have given me of your confidence, which displays great zeal, power of memory, and attention. I am about to go out of town and shall not be settled in town till the end of January. I will then see you at any time you wish. It will gratify me to be of any service to you. I wish it may be in my power. I am, sir, yours sincerely. Now let me go back. Look, that's a document, as I told you, which is so incredibly beautiful. And it is sent to the man who is the author of it in a way. And what does Humphrey Davy say? I'm far from being displeased. Only an Englishman can say that. You know, I mean, if you were a Welshman, you'd say, I'm overwhelmed by it, but I'm far from being displeased. Well, in no time at all, he appointed him, and I'm jumping through the months and the years. Well, not the years. In 1812, Davy also got married to a niece of Sir Walter Scott, Mrs. Aprice, who apparently was a very difficult lady. Anyway, they went on a continental tour of 18 months, a mobile laboratory, and Faraday was the amanuensis. And they visited Paris, Montpellier, Florence, Como, Rome, etc., Geneva. Here they are in Paris. Now, you know, in 1804, Paris had really seen some fantastic science. Look, Gay-Lussac and Biot had gone 25,000 feet up to test what the composition of the atmosphere was. Laplace was there, Ampere was there, many others, Arago. Well, they went on, they called with Volta in Como, because Volta had discovered the battery in 1800. And they went to Florence, one of my favorite cities. There's the Duomo there, the Ponte Vecchio is just there. The Boboli Gardens are there. Now, why do I mention that? Davy, who was extremely well connected, wanted to test the hypothesis that diamond was no more than carbon, just like graphite or cork. Many people disbelieved that. He knew that the Grand Duke of Tuscany had the best lens in the whole of Europe, and he got permission to borrow it. And they carried out an experiment in the Boboli Gardens, those of you who've been to Florence, in which he took a diamond crystal inside a large globe full of oxygen and used the rays of the light focused by that lens to burn it. And it burned completely to the oxides of carbon, thereby proving that diamond is no more than carbon. Well, he comes back after 18 months, he works in the laboratory, better equipped in 1814 than any laboratory in Oxford or Cambridge. And I say that with absolute no fear of contradiction. Right? It was terrific. It was largely Davy's doing. Here's his magnetic laboratory. Now here's the experiment that really mesmerized me as a 14-year-old when my physics mistress in the Gwendraith Valley, which is where I come from in Carmarthenshire, carried out this kind of experiment. You've seen it. It's been done a million times in every school. You have iron filings on a thick paper, and you put a magnet underneath, and you just tap it, and you see the lines of force. Now, Faraday believed in the reality of those lines of force, and I mean, this was his own creation, by the way. I mean, he used sticky paper, and this is from a photograph of the actual setup that he constructed in about 1836. And he believed, you see, that if you intersect these lines of force with a metallic object, you generate electricity. That is his understanding. In fact, Clerk Maxwell used to say of Faraday, who never knew anything more than arithmetic. He didn't know any algebra. Certainly didn't know one end of a differential equation from another. But Maxwell used to say that Faraday was one of the greatest theoreticians of all time because of the clarity of his thoughts. And Kelvin would repeat that. And in fact, if you read the papers that Faraday wrote within about a period of 8 weeks after his discovery on August the 29th, 1831, he really explains in words how you generate electricity by the intersection of lines of force. Well, he did so many other things. You know, if I had time, I could tell you about his work on colloids. This is the colloidal platinum that he prepared. And we know the date exactly because his notes are so very careful. It's in February 1857, and it's still suspended, you see. If that were a solution, say of permanganate, and I put this laser beam there. You wouldn't see it, no more than you can see it in a solution of air. But because it's colloidal and particles of this kind, this is some electron microscopy done in the chemistry department. Dennis, I was head of the physical chemistry till 1986. You gave me a 10-year lease of life there. Now, here's a very quick summary in reverse chronological order of what Faraday did. This is why I believe, and all scientists believe, he was a genius. Right? Colloidal methods, right? Nanocrystalline, you'd be called a nanotechnologist these days. Magnetochemistry, right? Paramagnetism, electrochemistry, the laws of electrolysis, the equivalence of voltaic static animal. I haven't told you much about that, but he did demonstrate that. Superionic conductors. He showed that lead fluoride was an ionic conductor, a very rapid ionic conductor. Improvements in the optical quality of gas, liquefaction of acids. Here we are. He was a fantastic analytical chemist. He could have been a very rich man, but he didn't really go for money. I mean, his religious conviction again said that such money as he had extra, he would donate and give. I mean, to widows, little children, and the poverty-stricken people. That was the method and the sort of ethic that drove him. But he did help Davy on the minor safety line. Contributions to physics, lines of force, concept of field, night magnetism, interconnected. This is how he begins his paper in Philosophical Man of 1845. I have long held an opinion, amounting almost to conviction, that the various forms under which the forces of nature are made manifest have one common origin. Beautiful. And you can read, as Pierce Williams and many other biographers have done, you can read into that his religious conviction. The reason why Faraday really never gave up in his studies, physics and chemistry and anything else, he believed there was always an answer. And Romans 1:20, which I'll come to in a few moments, many of you know it off by heart, that was really the guiding star for him. These are some of the other things that he did. I have to tell you that he went through a walking journey through Wales, right? Now, Faraday, this is a book written by David Thomas, who's not related to me, but he was an electrical engineer. It's a fantastically interesting book. Because Faraday was interested in technology also. He wanted to go to Merthyr Tydfil, because that's where the largest iron and steel works in the world was at that time. He wanted to go to Mynydd Paris Mountain, which is in Anglesey, because that was the greatest copper mine in the Roman Empire. He wanted to go to Swansea because of nickel and various other things, and steel, and he did. And this is the path that he did. He skipped Aberystwyth, and I'm sorry about that. But he went to Cadair Idris, and he describes, there's a beautiful passage of how he met a 6-year-old girl in the Vale of Neath who spoke no English. And he had a long conversation with her. She spoke in Welsh, and he in English, and they got on famously. Now, here's the famous notebook, August the 29th. Here's his own writing. Experiments on the production of electricity from magnetism, etc. I've had an iron ring made, soft iron, 7/8 of an inch thick, 6 inches in external diameter, wound many coils of copper, etc. Now let me tell you, without going through laboriously all the detail here, this is what he was after. He had a circuit there, right, in A, and he had another circuit in B. Now he hoped that by passing a current through A, he would induce a current in B. But it never happened, until he noticed, on doing his careful experiments, that when he made contact, when he had current passing through there was a flick in that circuit. And when he disconnected, there was a flick in the other way. I'll show you that. This is a good galvanometer. This is the sort of an illustration. This is my hand there with a magnet. Now, it's stationary, right? See what happens? I put it in, there's a kick. I pull it out, it kicks the other way. So if I do that repeatedly, I've got AC current. That is electromagnetic induction, right, in a word. I mean, of course, there are many other people that have come to give us the electricity that we have. from Tesla to Edison and others, but that is the sensational experiment that Michael Faraday carried out, electromagnetic induction. Well, his laws of electrolysis, as I've told you before, amongst the most accurate generalizations. Yeah, these are things, you see, Feynman, Feynman, who was, I mean, John, you knew Feynman, you were at Caltech with him. Feynman was probably the most brilliant popularizer of science and one of the deepest thinkers about physics in the last century. Feynman says that the most dramatic moment in the history of science came when Michael Faraday, in the basement of the Royal Institution, demonstrated how electricity and matter were one and the same thing, were interconnected, because matter is electrical in nature. And this is really an extraordinary achievement. Just to show how hard he worked, because the amazing thing, as a Sandemanian, he didn't believe in there being a clergy or priest or anything. He and his congregation knew the Bible almost by heart, which meant that he read the Bible effectively and repeatedly. I mean, one of the most dramatic things, I lived in Faraday's house for 5 years, washed my hands in his sort of wash basins and slept in his bed and all that, and worked at his desk. When you think that religion probably meant more to him than his physics, than his science, it is just astonishing what he accomplished as a scientist. Where did he have time to do all this? Because look, he used to write copiously. He was a compulsive writer. And if he saw a beautiful sunset, he would describe it. I mean, if he saw an unusual rainbow, he would describe it. He was a compulsive writer. He published 20 original papers in this period, delivered 17 Friday evening discourses, gave 6 Christmas lectures and 48 daytime lectures in the RI, delivered 75 lectures in the Military Academy in Woolwich, and then had extensive correspondence with all these. Ampere, Babbage, Berzelius, Mary Somerville, Plato, Herschel, Whewell helped him coin a few words, and a memorandum, 7,500 word memorandum, which he wrote in French, because when he went with Faraday to the continent, he learned French and Italian. That was the genius of the man. Now, when Abdul Salam, the first Muslim Nobel Prize winner in physics and in science, gave his discourse in the Friday evening, way back, he drew this cartoon, the first attempt to unify electricity and gravity. Here are the balls there, here's Michael Faraday, forces of the world unite. See, Faraday believed, and he carried out repeatedly, no end of experiments, that there was a connection between gravity and electricity. In fact, at the end of his paper in Philtrans, which is about 90 pages long, the final paragraph reads, "Here end my experiments for the present. The results are negative, but they do not shake my belief that there is a connection between gravity and electricity." Such a beautiful example of the intellectual honesty. Well, he was an environmentalist also. He wrote a letter to the Times, which Punch magazine caricatured. Here he is giving the Christmas lectures in 1856 with Prince Albert. Now, the former Conservative MP for Cambridge, who was a close friend of mine, Rhodes James, wrote a book about Prince Albert and claimed, amongst other things, and this is not the subject for subsequent discussion, but that it was Prince Albert who saved Cambridge. And there's a great deal of truth in that. Because by the time he became the regent, Cambridge was slipping fast. And he galvanized by working on 5 particular masters and regenerated the excellence of the place, because it was fast sinking in wine and dining and so on. Anyway, here's the population for a snapshot painting of Faraday and the 2 young princes. Now this gentleman here, that's Charles Wheatstone. When Faraday lectured at the Royal Institution, Charles Darwin occasionally Charles Dickens, frequently. Charles Wheatstone invariably attended his lectures. And Wheatstone was an extremely nervous man, a brilliant man who, in fact, not only was he a great physicist, but he was a great musician. I think he invented the accordion, I believe, something like that anyway, and the kaleidoscope and various other things. Faraday persuaded him to give a Friday evening discourse, and he accepted. Now, the tradition, as the three gentlemen here well know, and as I well know, is Faraday set in store a practice that if you were going to give a lecture, you shouldn't be talking to people beforehand. You should be thinking about your lecture. So he, after dinner, in the director's flat with various guests, the director takes the speaker and puts him in a room and lets him lie down there and think about his lecture. And at 2 minutes to 9, the director, Faraday on this occasion, comes to pick up Wheatstone to take him to the lecture theatre. And lo and behold, he opens the door and finds that Wheatstone has run home. He was so petrified. So Faraday had to give the lecture. In subsequent years, George Porter told me, one would lock the door, which is another meaning of Faraday cage. Now, here's a beautiful piece of English prose. I was delighted to find in Japan about 3 years ago that this is being set to Japanese children to translate into Japanese. This is Crookes, the great Crookes of Crookes' Tube, Crookes who discovered thallium, did so many brilliant things, president of the Royal Society, president of the various other societies. Look at this. It's a history of the candle. Now the candle, when Faraday gave his first 6 lectures on the candle, it was the high-tech instrument of the age, you know. I mean, think how it transformed life. It illuminated people at night. People could read. And it was quiet, silent light and illumination. From the primitive pine torch to the paraffin candle. How wide an interval between them, how vast the contrast. The means adopted by man to illuminate his home at night stamp at once his position in scale of civilization. The fluid bitumen of the Far East, blazing in rude vessels of baked earth, the Etruscan lamp, exquisite in form, yet ill-adapted to its office. The whale, seal, or bear fat filling the hut of the Eskimo lamp with odor rather than light. The huge wax candle on the glittering altar. The range of lamps in our streets, all have their stories to tell. All, if they could speak, and after their own manner they can, might warm our hearts in telling how they have ministered to man's comfort, love of home, toil, and devotion. Beautiful, absolutely beautiful stuff. Yeah, here are the discourses that only some of them Faraday gave about 800 discourses. It is an incredible number. Here are some of the titles. And the audience figures are given here, which is very revealing, by the way. Notice that on magnetism and light, magnetic conditions of matter, a very large crowd. If you want a large audience, choose a small title. You see 367, right? Now, these two ladies, Mary Somerville and Ada, Countess of Lovelace, the daughter of Lord Byron, both admired, in fact, in the case of Ada, there was an infatuation that she had. She wrote to Faraday and said that she wanted to be his bride in science, which you could read psychologically into that, and to repeat all his experiments. Now, Faraday was a busy man. He didn't want suggestions of that kind, right? And Mary Somerville, who discovered him, I mean, she's the Somerville of Somerville College, brilliant woman. She translated into English Laplace's treatise on mechanics, for example. Formidable mathematician and a geographer. She wrote to Faraday far more frequently than he could reply to her. And in one letter written about March 1834, Faraday begins, and this is so beautiful, he says, to Mr. Mary Somerville, I can no longer deny myself the pleasure of answering your letter. So I've used that several times since. And now there was another lady, wonderful lady, the daughter of a doctor in London who married a Swiss doctor who founded the Royal Society of Medicine, Mrs. Massett. She used to attend all the lectures of Humphrey Davy and was absolutely galvanized and enthralled by them. So she decided to write a book on conversations in chemistry, intended for young ladies, by the way. It's a fantastic book. You know, this went into 15 editions in America alone. It far outsold all the published works of Lord Byron. And Faraday used to read her work, and later on she used to come and listen to him. And he adored her. You know, she's much older than he was. Now, his Bible in the Royal Institution, we were given by a relative of Faraday's wife, who was Sarah Barnard, who was also a Sandemanian. Her father was a silversmith. His father was a goldsmith. Now, as in everything else, Faraday had a meticulous approach to everything. This notation, which only he understood, meant that certain verses signified certain things to him in the Bible. One of his favorite verses is in the book of Job, chapter 9. If I justify myself, my own mouth shall condemn me. If I say I am perfect, it should also make me perverse. You see, there it is. If I justify myself, my own mouth shall condemn me. If I say I am perfect. What he was saying, and in everything that he did, this is borne out. Don't boast about yourself, right? Just be reasonably modest. But, you know, be kind to others. And he was exceptionally kind to others. I mean, people who wrote to him, he always answered. In fact, his near contemporary Jane Austen encapsulates a similar sentiment in one of her letters. She says, incline us, O God, to think humbly of ourselves, to be severe only in the examination of our own conduct, to treat our fellow creatures with kindness. And that really was the sort of motivating principle which drove Faraday in his religious life. Now, Romans 1:20. I had the privilege in 1991, when we were celebrating the centenary of the birth of Michael Faraday, of organizing a very special service in Westminster Abbey. And I wrote to John Habgood, who is well known to many of you, and invited him to preach the sermon, which was a brilliant sermon, by the way. I have a copy of it here still, and it says on the top, embargoed until 12:30 September 20th, 1991, but I can tell you all about it now. He says at the beginning, I was tempted to choose as my verse for this sermon, there were giants on the earth those days. And then he describes the magnitude, the stature of the genius of Faraday. He said, but that's not the real reason why I have not gone for that. I want to go to this particular verse. Ever since the creation of the world, his invisible nature, namely his eternal power and deity, has been clearly perceived in the things that have been made. And really, Faraday believed in that, and when he preached in the little Sandemanian meeting house close to St. Paul's, he often preached to this sermon. So he believed in it passionately. This is it in the New English Bible. I was asked whether this talk was going to be in English or in Welsh. I can read it to you. Can you say, anweledig bethau ei greadigaeth greadigaeth y byd wrth ei ystyried? That's Romans 1:20 in Welsh. Now, you know, I don't know the Bible in English. I know it far better in Welsh. There are certain things in the Bible, like tell it not in Gath, publish it not in the streets of Ashkelon, which are better in English than in Welsh. But most of it is far better in Welsh. Anyway, ever since the creation of the world. Now, you see, this is really profound, because Faraday honestly believed that what was there required further examination. When people ask me, how do you account for the genius of Faraday? I say, well, for every question that he posed, he believed there was an answer. And I think that goes back to his religion. I can't help thinking of it. Now, you know, not only was he a brilliant scientist, a brilliant man of religion, a brilliant human being, He also built his own furniture. Can you believe that? So when I used to wash my hands before going to bed at night, and I used to look at this, I'd feel it's 10 to 12 already, so I go back and work harder, because I don't feel I've justified myself. Here's another fellow, Peterhouse, Sir James Dewar, giving a Friday evening discourse in 1904 on the liquefaction of hydrogen. Here is Sir Oliver Lodge. Here is Ludwig Mond. Here is George Matty of Johnson Matty. Here's Lord Rayleigh. Here's James Crichton Browne, the Queen's physician. Here's William Crooks. Here's the Prime Minister of the day, A.J. Balfour. Here's George Gabriel Stokes. Here's Lord Lister. Here's the 84-year-old Calvin and the 36-year-old Marconi. Now, what would have happened? Health and safety at work did not exist in the So if there had been an explosion of the intellectual and political life of now, again, my late wife used to tell me that the finest thing you've ever done was to convince the Bank of England to get the £20 note. And of course, it is really quite a nice feeling that you can get the Royal Institution here and all the things. Now he's pointing up there. Let me point. See, look. Those are all the words that he, with some help from Hewell, Master of Trinity, brought into the English language. Electrode, anode, ion, cathode, anion, electrolyte, etc. There are the lines of force on the perimeter of the £20 note. Now, here's Michael Faraday. What can I say? I will say one thing, I think. Just 2 minutes. I'll tell you why I want to say this. It illustrates the integrity of the man and his concern for conveying the right moral message. After he'd finished his Christmas lectures on the chemical history of the candle, on the very beginning, or the very end of his 6th lecture, he says, "Thus you see the analogy between respiration, breathing, burning, whatever it is in your body, and combustion. All I can say to you at the end of these lectures is to express a wish that you may, in your generation, be fit to compare to a candle, that you may, like it, shine as lights to those about you, that in all your actions you may justify the beauty of the taper, by making your deeds honourable and effectual in the discharge of your duty to your fellow men."
Well, thank you very much, Lee, for that, and I'm sure that's also stimulated some questions and discussions, so over to you for questions, please. Thank you. Who wants to be the first? I have a question, actually, just while people are thinking a little bit. What about his sermons? I mean, were they ever written down? Were they extemporary and therefore never written down? He didn't have notes? So how was that?
No. Well, there are many people who paid particular attention to the religious convictions of Faraday. There's a gentleman in the University of Leeds named Cantor who's written extensively on this. But there are only a few fragments, it seems, Dennis. They were a sort of almost secretive a class of people. I mean, they were strict, Faraday was denounced by them for attending one religious service in the Church of England, because he didn't want to go to the Church of England. When I arranged this special memorial service in the Church of England, I had a few hate letters, from experts in Faraday saying you shouldn't do this. Faraday wouldn't have wanted you to. Well, there was a stone there in Westminster Abbey anyway, so my reply was, well, if you take the stone away, I won't proceed any further. No, there are no real indications of what they were, but one or two people testify to the fact that he was a very engaging speaker. There were others. I mean, they were largely working class people, artisans, very many of them. bookbinders, several, booksellers, but butchers and others. They were a very strict sect. And I don't know as much about the Sandemanians as others do, but I can assure you that there's very little information about the sermons that he preached.
Okay. Please, yes.
So you were reported in one of the newspapers having said last week somewhere, I think British Academy actually, that planned discovery is impossible.
That's right.
In the light of what you've just told us about the immense industry of Michael Faraday in pursuit, it seems to me, of specific aims, I wonder how you feel that wonderful summary sits.
Well, I still retain the belief that you can't plan discovery. I mean, the examples I gave in that talk, which was very briefly reported by Melvin Bragg, was that, you know, nobody really could plan the discovery of X-rays, of nuclear fission, of polythene, of shall we say, immunosuppressive drugs. You discover these as a result often of an accident. You can plan mission-oriented research and applied research. If you want to improve a phosphorescent device or a gallium nitride material, which Colin Humphreys and others are doing, you can have a strategy to try out various things. But, you know, the discovery, for example, magnetic resonance imaging, let's take that. It was physicists in Harvard and Stanford who were really cursing the fact that when they looked at the gyromagnetic or magnetogyric ratio of a proton, it seemed to shift depending on the material in which you had it, whether it was ethanol or methanol or acetone or whatever. Until it was then realized, well, you know, this is a wonderful chemical tool. Organic chemistry these days would be impossible without that discovery of magnetic resonance, nuclear magnetic resonance. And then later on, somebody else realizes, well, now we can think of imaging. These major advances come through discoveries, like electromagnetic induction. Right? What he was looking for, he didn't find. But he was so careful in his observations. And that was one of his other facets of distinction about him. I mean, Brian Pippard, who many of you knew, he wrote the preface to this book on Faraday that I wrote. And the point that Brian made was, you know, he had that knack of peripheral vision, of looking for things which others wouldn't look at, and noting an anomaly and so forth, and reporting it. I mean, on top of all that, he was so accurate. You know, when he isolated benzene and measured its freezing point and boiling point, it's only about 2% different from the accepted value. Now, you know, think of it, 1826. Bet you many of your students go in are not as good at that. Within 5%, they probably has condemned him. But he was brilliant.
And just to mention that the Faraday logo has, you can read about it on the website actually, its roots, but one of its roots is in the benzene ring, just to flag that up. So I think resist making that point. Other questions? Yeah. Colin, yes.
No, wonderful lecture, John. Thank you very much. So Faraday achieved so much. Do we know how he worked? So, for example, did he work on one topic at a time, sequentially, or was he working on topics in parallel? Do
No,
we know this?
usually sequentially,
Yeah.
and prodigiously long hours. I mean, no coffee breaks. And he had one assistant, Sergeant Anderson, for about 36 years. They hardly talked. And they would be 12-hour days. I mean, it was astonishing. No, it was, because we've got his notebooks, you see, every single entry in his notebooks. So William Bragg, when he was the director of the Royal Institution, decided that he would get those printed, and they're available. I mean, you know, they're in the university library, I'm sure. And you can look, you can see there's an index to it. You want to find out the efflorescence of sodium sulfate decahydrate, which is a particular example I had occasion to look to when I was in Bangor, North Wales. You know exactly when he did it, what time of day it was, and when he returned to it, you know. But it's usually sequential. Yeah.
Yes, please, yes.
Faraday would have been 68 when Charles Darwin's Origin of Species was published. Did Faraday have any reaction to the book?
Very interesting question. I'm often asked that. You know, Faraday believed in the literal word of God as he read it in the Bible. And he believed that nature was the hand of God. Right? He was serene in the security of his religious conviction. Nothing could shake him from it. And it seems that when, in Albemarle Street, it's the same street, Albemarle Street is where Faraday and Davy did all this work, where Jane Austen published her books, where Lord Byron published her book, where Charles Darwin published her book. No, he didn't seem to have any impact whatsoever, to my knowledge.
I think I'm right in saying there's no evidence he ever read The Origin of Species, is there? Or do we know
I
that,
don't
or
know. I
no,
just don't know that.
No.
I mean, there are lots of people. I mean, one of the most authoritative individuals on Faraday, I find, he's recently passed away. He was at Cornell, Pierce Williams. Despite his name, he's Italian, actually. But wonderful books. And Colin Russell, you know, who in my very first visit to the Faraday Institute talked on Faraday, actually. And Colin would probably know that better than anybody else, I should think.
Just mention, if you wanted, we have a Faraday paper by Colin Russell on Michael Faraday. If you wanted some of the material we've been hearing about, other things, then that's available for free download actually off our website. So
Yeah.
Colin has a biography also of
Yes,
Michael
indeed.
Faraday,
Which
Oxford
is
University.
very fine,
Yeah.
very fine.
I think we have time for perhaps one or two more questions, so anyone else would like to ask a question? Yes, Bob, yeah.
Did you work on
Yeah.
Sunday?
No, to my knowledge, he never did. But he used to work on Christmas Day because he demonstrated the electric motor that he built in 1821 to his wife, who was preparing the food, it seems, and he called her down. Right? He was working on Christmas Day, that's for certain. That's documented. No, I mean, I can't imagine that he would work on Sunday. Yeah. It is utterly astonishing when you, the more evidence you see of the genius of Faraday, everything, he had a clarity of vision, he had a clarity of expression. And when he wrote in such immortal terms, I've long held an opinion, amounting almost to conviction, in common, I believe, with other lovers of nature, with the various forms in which the forces of nature are made manifest. And one, I used to edit journals, I never had an opening paragraph.
Good. Well, we want to leave time for this discussion group to meet, particularly before Sir John has to hurry away. So that's a little reminder. Rather than people coming up and asking individual questions afterwards, if you want to engage more and have a bit of a discussion in a group, I'm going to suggest we break now in just a moment. And then rather quickly, if other people could sort of move at least to the back for your talk, and then discussion group can meet around the front here, and then you can ask further questions for some time. But first of all, let's thank Sir John for a really wonderful talk.